Question 2 is our normal distribution question. We're talking about the diameter of a pool ball, and it tells us that D is normally distributed with a mean of 57.15 and a standard deviation of 0.04. So the variance is, of course, 0.04 squared. And the first thing asks us, what's the probability that D is less than 57.2? Standardize it by taking away the mean and dividing by the standard deviation. Tap that into your calculator and you find out that that tells you we want the probability that Z is less than 1.25. Now you can grab your normal distribution tables and look up 1.25. I'm going to do it on the calculator though. Distributions, probability of 1.25, and it tells me the answer I want of 0.894. Second part is between two values, and the way of course we do that is we work out the probability of it being less than the top one, take away the probability that it's less than the bottom one. This one is the one we just done, so that's 0.894, done that one already. Take away, we've got to convert that again, 57.1 minus the mean divided by the standard deviation again, and that turns out to be minus 1.25. Of course, the beauty of these calculators is we can just tap in minus 0.25, let's put that in there, and that gives us 0.10. So we've got 0.894 minus 0.10565, and that gives us our answer to that part there as 0.789. 0.789. Let's move down and look at the second part. And we've got two ideas here. We've now got a group of 16 of them. And the first thing he says, every single one of these 16 has got that probability less than 57.2 millimeters. We know the chance of being less than 57.2 millimeters from earlier. It was 0.894. And I'm going to use the full value of that, 0.849435. That's what we got in the calculator. We don't want one of them. We don't want two of them. We want all 16 of them to be less than that. So it's that times together 16 times, and that gives us 0.168. But the second time, we're now asking to find out the mean of these 16. So this is when we're talking about finding out the distribution of the means. And of course the distributions of the means are normally distributed, the means still being the same, and now the variance, which was 0.04 squared, is now 16 times smaller because we've got 16 of them. We want the probability that the diameter is greater than 57.16. So now just convert as usual, 57.16, take away the mean, divided by the standard deviation, which is the square root of that thing, and that figures out just to be 1. The probability that Z is bigger than 1 is 0.159. Notice the difference here between these two questions. This one here is talking about all 16 of them, so we're doing each probability here, and this one was talking about the mean of them, so we're doing a whole new distribution for the means.